And good morning, everybody. We're almost done. So review today, test tomorrow, and finish. Now, look at this. So if everything's in A for U, right? And then from there I'll go, whether part of it's in B, some of it's in C, very little is in D, hardly anything at all, then it's called an incomplete. Incomplete. Most of you are looking at A's or B's. Nice job during this time. So I'm proud of everybody. You guys have done a great job. For those who are watching this, okay? Gosh, I wish I was in class with you because you guys were actually a really good group. I actually liked, you guys made me like freshmen. Thank you. And I miss you because it was a really good class. Anyway, let's take a look at the homework. So first of all, I want to write this down. So on the test, there will be no proofs. None. Okay. So let's take a look at it. Okay. So I drew a triangle. They wanted it obtuse. It has a height of 3, and there's the base of 2. Okay. Now they wanted 2W, so I just counted it as like however squares. But if that's 2W, that'd be half as big. So there's my rectangle. On 3, I actually found the lengths using Pythagorean's theorem. So this triangle here, like 2 squared plus 5 squared, I got the square root of 29. Same thing here. So then they're both got to be the same square root of 29. I did the same thing here. I did for this length here, I went 5 squared plus 5 squared, square root of 50. Did the same thing here. You can see this triangle here. You can find this length, okay, same thing, square root of 50. And I obviously know that they share the side PR, so PR is equal to PR, okay? So I knew the triangles grouped by side, 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 okay? And then on number 4, again, I went through and I found the lengths of the sides, and I used Pythagorean's theorem. I went, see my little right triangle here, to find that length. So I went 3 squared plus 1 squared equals square root of 10. It's the same thing, you can see the exact same little triangle there. Pythagorean's theorem turns up to square root of 10. I need to find this length here. You see the green triangle, so I went 3 squared plus 3 squared, square root of 18. And of course you got the exact same triangle here, square root of 18. So what I have is all 3 sides equal. So if that's the case, then if this is equal to this, and if this is equal to this, then that's got to be a midpoint, okay? 5 is a little bit harder because they wanted the midpoints on these. So I did in terms of m's. I'm going to found the midpoints. The slopes were easy. Down, up 1 over 3, and this one's down 2 over 3. The slopes are there. So, but the midpoints are in terms of m's, okay? Here's the midpoints. And then finally, on the last proof, I had to find the value. And I used Pythagorean's theorem, but I used it in terms of h's and k's. And I was able to say they were congruent by side, side, side. Okay, you will not have any of this stuff on your test. No proofs at all. Okay, none. Okay, we've seen them. You know what they're all about. Enough. You'll never have to use them ever again in your life. Okay. All right, moving on. So what about today? So today's a review about the test. So let's take a look at the test. The test is all about triangles. Okay. So let's go back. We learned, believe it or not, that this exterior angle is equal to these 2 remote interiors. So we know that this exterior angle, we learned this like in the very first section of chapter 12. We know this exterior angle, so this 3x plus 6 is equal to the sum of these 2 interior angles. So it's equal to 24 plus my 2x plus 16. Oh, sorry, 18. And then solve for x. Once you get x, plug it in, okay? Okay, I'll let you do that, okay? You get x equals whatever it may be. Once you get x, plug it in, you'll get the other angles, okay? 2, let's take a look at 2. So if I take a look at 2, there's 2 things going on. One is an equilateral triangle, okay? So if that's the case, then I know some things that are equal, okay? The second thing I know is I've got an isosceles triangle, okay? Okay, so I've got that equal to that, okay? Now, let's see, that's an angle, right? And these are all worth 60. So this one's a little bit harder, but if these are all 60 degrees, because it's equilateral, 60, 60, then this angle here has to be 120 because out of 180 degrees, it's got to be 120. So that means that these 2 angles here have to be, let's see, 120, 180, minus 120, right? Because I'm looking at the green triangle here, right? How many degrees in the triangle? 180. That's 60, right? and then I have to divide that by 2, so I get 30, okay? So that means this angle's got to be 30 degrees, and this angle's got to be 30 degrees, okay? Now, so let's go straight to here. 3x minus 5 equals 30. I know that this angle, 3x minus 5, has to equal 30. 3x equals 35, divide by 3, and I get a decimal, but life goes on. 35 divided by 3, and I get an answer about 11.666, or x is equal to 11 2/3, okay? Now, once I get that, then I can plug that in, right? So to get y, I know that these two sides have to be equal, right? So therefore, if that's the case, then these two sides have to be equal. So then I can take my y minus 4 and set it equal to my y plus 12. 5y, sorry. 5y minus 4 has to equal my y plus 12, and I'll let you solve for y, okay? Okay, 3. Here's what I know. 180 degrees in a triangle. If I take away the 90, I'm left with 90. So these two angles have to be complementary or add up to 90. So I'm going to go 19x minus 1 plus 13x minus 5 has to equal 90. I'll let you solve for x, and when you get x, plug it back in, okay? All right. Easiest problem of all. I know of 12, 12, 12, so here's what I know. 60 degrees, 60 degrees, and 60 degrees. So if that's the case, then 2x equals 60, x is 30. And then you got it from there, okay? Okay, now, 5, name it. So we're going to name it by sides and by angles. Okay, like isosceles, like scalene. Let's write some of these down. We've got isosceles. Let me write it down on a sheet of paper, okay? So I've got words like let's go scalene first. Scalene. No sides are equal. Isosceles. Two sides are equal. And of course, equilateral. That's by sides. Okay, let's look at angles. So we've got acute triangles. We have right triangles, and we have obtuse triangles. Okay, so let's take a look at number 1. Looks like it's an isosceles right triangle. Okay, boom. Let's look at 6. Looks like it's a scalene obtuse. All three sides are not equal, and that's an angle bigger than 90, so I'm going to go obtuse, scalene. Number 3, you could either call it equilateral, or you can call it equal angular. It's usually equal, or you can call it an acute. I like acute because they're all less than 90. Equilateral. There we go. Boom. Okay, let's look at number 8. Okay, state theorem. Remember, it's not a proof. This is not a proof, so just state the theorem. Well, I know that this side has to be equal to itself, so it looks like side, side, side. So we're not going to do any proofs. You're just going to say side, 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 and label your figure, okay? Number 3. Okay, I always need 3 things. Always need 3 things. Let's see. Here the side, side, side. We've got side, angle, side. We're going to have an angle, side, angle. We're going to have an angle, angle, side, and we're going to have this thing called the hypotenuse leg. Okay, those are all ways we prove triangles. There is no, by the way, no side, side, angle. Okay, all right. So let's take a look at number 9. Okay, here's what I see. That angle is equal to that angle by vertical angle, so I see an angle, side, angle to an angle, side, angle. Boom. That's all you gotta do is mark the figure, tell me which one. You don't have to do any proofs. This is a right triangle, so that means that is definitely a hypotenuse. They share that side. All right, they share that side, and that's a leg, so I'm going to call that hypotenuse leg, okay? 11, midpoint of BC. Well, if that's the case, if I've got a midpoint, That means that this side is equal to this side, okay? I've got parallel lines, so I could either say that this angle is equal to this angle, right? Okay, and then I also can say maybe this angle here is equal to this angle here, and that would give me angle, angle, side. I could even say this angle is equal to this angle by the parallel lines, but either way, still I'm going to get angle, angle, side. Okay? All right, 12. Cruising on this. It's easy today. One acute angle of a right triangle is 54 degrees. Okay, let's draw a triangle. I always think the picture always helps, okay? 54 degrees. What's the other? All right, well, let's just go 90 minus 54, okay? 13. The vertex of an isosceles triangle. Okay, isosceles. Let's just draw it like this. And it says 102 degrees, so I drew it kind of fat. See how I drew it kind of fat? Find the base angles. Now the base angles are equal. That's what I know, because it's an isosceles triangle. Okay, so if this side is equal to this side, then the base angles are equal. So that angle is equal to that angle. Okay, so if how many degrees in a triangle? 180. Let's subtract out the 102. Find out what's left over. I don't know. 180 minus 102. I could probably 78. I did that in my head. Now, 78 has to be divided between the two, so divide that by 2, and I get both angles to be 39. So 39 degrees, 39 degrees. Okay, so here's the deal. This is the review. If you want to go ahead and take it from this film and just watch it and do it on a separate sheet of paper and send it to me, great. If you want an actual copy of this, ask me and I'll send you a copy. Okay, so that's all I have, and then tomorrow will be the last day of recording, and then we're done. So again, if you can get everything into me, you will get an A. Okay, all right, there you go.